Right, I'm going to have to handhold this, sorry about this, but this is the reason why I'm doing this spindle, while replacing it. There's a few annoyances and a few problems. This is the change gear, this is the main gear on the spindle. And as you can see there from the actual key, the key is very shallow and wide. I don't have keys that size, and I know damn well that I'm not making one. If I'm going to, if a temper measure does. It's got a deep keyway there, so I've got space, but I'd like to make that keyway deeper and more compact for the actual keys that I've got. It's also got a lot of slop, as you can see there. I think this is a spare spindle that's been found for this lathe in the past. There might have been a problem with the original spindle, so they found a spare spindle. It's not quite right. Because everything back in 1912 to 1920, it was all rushed, it was all made to fit. So you'll have batch numbers like that. If it says it on this gear. Got to be careful now because that's got a bearing washer. There. Somewhere on that gear, yeah, there. 588, it's down at the bottom. 588, they'll make bits and then they'll make them to fit the parts that are going to be going on. Then they'll send the parts out for building, and then the workshop that's going to be building them up, they'll just match the part numbers up so they know which parts fit each part. Now the problem is when you get with these old lathes, when you get spare parts, they don't always fit. So anyway, that's one problem. Second problem, the key for the ball gear is very shallow. It's only about 0.5 millimetre deep, believe it or not, 0.5 millimetre to 1 millimetre deep on the spindle. I'll show you that in a bit. But it's also a little bit too wide for the key that's in this ball gear. And the key that's in this ball gear is machine perfect for this ball gear. So I didn't want to mess about with that. So it's got some slop. It's a bit hard to do it now because I haven't got the chalk and I'm holding the camera in my hand, but when you hold the chalk, you can move the ball gear about 1 tooth distance left and right. So that's very slack. You can hear it if you've had it in reverse and then you put it in forward. As soon as the tool touches the work, you can hear a clang of the spindle trying to stop, then the ball gear catching up and then dragging it again, dragging it round. That's another problem. I hate that spindle nose. It's got a long thread and it's 1 inch 7/16 10 TPI. There is no such tap, there is no such die. So every single backplate or fixture or faceplate or anything that I want to put on this, I've got to internally thread it all, which I don't like doing. What I prefer to do, because I've got about 3 spare backplates that I used to use on a wood lathe, which are M33 3.5. They're spare. I can get 6-inch faceplates from Axminster, quite thick faceplates, and machine those up to use them as backplates. Because I've got a fair few chucks there that I want to start using. I've got that big one there and it's got a gear on the back of it. You know what I mean? It's not fantastic, but that's what was knocked up by somebody in the past, and it looks like they've ground the tips down a little bit so it fits inside the chuck. I'd like to replace that, and I've got a few others underneath the bench as well. So that's about 6 backplates that I need to make up, and I don't really want to be threading them all, so I'd rather just buy the backplates, you know what I mean, and just machine them down. Because trying to find a 1 inch 7/16 10 TPR backplate, you got no chance. Yeah, so that key on the spindle, I'll show you that next. Right, this is the spindle. It's got a lot of damage. You can see just there, and that's where the bearing sits. So the rear bronze bearing, they are a very strange design. That's another reason why. I can't remember if I mentioned it already or if I'll mention it later on in the video, but rather than make new bearings, because these bearings are a little bit loose, I need to make a new spindle anyway, so I might as well just make the actual landing places for the spindles just that tiny little bit wider. So it's got quite a bit of damage on there. Sorry, the screen on this camera is to the left, so I'm like this all the time, looking at it through the camera. So it's got quite a bit of damage there all the way around. That key there is very shallow. Basically it's just a step there, a step depth. Now the key, because the design of this, if you've got lathes that you're thinking about doing work to that are a similar design to this, the bearings go in from the left to the right. Both of them do. So the bearing's got to be in first, and everything else has got to be in first before you actually start sticking the spindle through. And for that reason, you can't, you know what I mean, get the spindle in there first, put the key in, and then slide everything together. So that's the reason why the key is in the ball gear already, and unfortunately, because the actual step up isn't that much, all they've done is they've just keyed that section there. So what I plan on doing with mine is making that deeper and actually having the slot all the way across. Being careful of those edges obviously, because the pulley spins when it's in back gear. The ball gear stays where it is, and then the pulley actually spins round on the shaft itself. So I'm going to have to round the edges off a little bit so it doesn't gouge the side of the pulley. But then that's going to be deeper. The key in there, I'll shim that as well, because that's actually sunk into the wall of the ball gear, the inner wall, by about 5 or 6 millimeters. It's very deep, considering how shallow that is. So I might shim that out by about 2 millimeters and drop that down by 2 millimeters. That's what I meant about the thrust bearings and that thin collar that I had to make up, brass collar. So about 0.5 millimeter wall thickness, that is. I decided to put that there instead of right at the back. It's supposed to be just there, but there wasn't a lot of space. I couldn't find a bearing the right size, so a thrust bearing and 2 washers the right size for spacing. So I decided to just make a HDPE or Delrin, I can't remember now. It's either Delrin or HDPE, high density polyethylene, and put the bearings at the front here instead. That's the washer that's stuck in. If I blast that with there, I know what's going to happen. It's going to fall straight down there, so I'll just leave it in for now. So yeah, that's why I want to change it all. Oh, that's took me an hour and a half to go from 55mm diameter down to 39. The section at the top there, wow, that's still quite wham. The section at the top here needs to be about 38.4, something like that. I've got the measurements down there. So I'm rough turn at the minute because the expansion as well, because of the heat. When it cools down, it's going to shrink. So I don't want to take it down to diameter. So when it cools, it's going to shrink a bit. So all the spare is up at the headstock spindle end. There's quite a bit there. There's still about 60, but I only need 40 millimetres length of length there. It's about 60. So what I'm doing now is starting at this end. I've got no spare here at all, so I don't want to start from that end, work all the way down there and then be short here, not having enough. So I'll start here, work that way. So if I need to take a little bit more, fine, I can do. Yeah, that's took an hour and a half to go down from 55 down to 39 and 345 millimetres. Sorry, yeah, 345 millimetres. Something like that. The taper as well, I've never really checked the taper properly. But the taper in this, it's got a 0.2 of a millimetre taper throughout that whole length, so I'm not worried about that. So what I'm going to do now is I need a length of 122. This is highly accurate. 122. Measure from that way around, eh? That section I've got to take down to 32.5. This in itself has got a slight step as well. The phosphor bronze bearing sits about that long. I've got those measurements, but it sits about that long, and then that section there is about 0.5 millimetre less. About 0.5 millimetre to, in fact I'll tell you. Yeah, 0.5 millimetre, and then there's a thread on the end of it which is even less again. So this, I'm going to take this down to 32.5. It's currently 39. So that's 7. Going down by 6 for now. So what I'll do is I'll pull this away and then move that in by 3 because we're working on the radius on this. And then when I've gone 3 by this, I know that I've took 6 off the diameter. You know what? I could see how to cut this video. I've got to set that short. I'll touch off and then go to 3. So I'll go 1.5. It's 1.5 off the diameter. Quite well for the old gal. This lathe, it was designed around 1912. A bit of a rush in the lead up to World War I. So she's over 100 years old already. Now I've had to do a bit of work to her. Well, let's face it, any machines that's built these days, imagine them running in over 100 years time. No way. Right, this is a much more accurate way of doing it. It's 64 to the end. A few people are probably going to comment about this. Oh, you should be doing this to your calipers. They're not the best calipers I've got. That should be 64. Slightly, you always double check, that's slightly less. Right. Well, where are you? This is 32. So I'll do a bit of touching. So that's 32.5, that's 32. And that is 31.3. And that is 35. You can trust me, I know me a lot better than this. It's been recorded. That's why I'm second guessing everything that I'm doing. That's going to be the thread. Well, if I zero that and then that's a mess about then, finding the depth. You just lost your mark. This is probably one of the last videos that I'm going to make. I haven't made a lot of videos. There's been a long period where I haven't made any because I always mess up when I'm making a video. Instead of thinking about the job, I'm thinking about the recording. Right, so today zero it again. I need to take that to 31.3. That's still red hot. That's 32.7, so I can take a millimetre off that, no worries. So that's half mil off the radius. That looks a bit much. That looks like more than a millimetre. .73, 30.71, that's less than what. This is what I'm talking about. It's good job I didn't go all the way, eh? Something up in there because I zeroed that. .32.7. 31.3. So I can take a millimetre off from that point. So half a mil off the radius. Down. And I think that there is a bust tip. Yeah. My God, that looks a mess. Currently 12:30 in the morning. I think I might give up. Right, turn the tip round. It's always good to have a fresh tip. I'll take it. This is a thread though, it's not, you don't have to be super light to the 0.01 of a millimetre. This is still technically roughing it. It's 31.57, so say 31.5. I need 31.3, so that's 0.2 off. I still need to take. So it's 0.1 for radius, 0.1 of a millimetre. It's 31.2, 31.3. 31.27 actually. We're close enough. Round it up. Right, onto the threading. I've got an insert, threading insert holder and inserts. The thread that I'm cutting at the moment is Whitworth, which is BSW. It's the same angle for BSF and BSB and all that like. The UNC, UNF and metric 60-degree inserts, so you need AG 60 for metric or UNC. For BSF, BSW, BSB and all that, like the Whitworth threads, you need 55 degrees, so that's AG 55. I'm doing an external thread, so that's signified with by ER. It's a size 16 insert, so the insert that I'm using is AG 55 for Whitworth, ER 16, so that's external, size 16, and then you need your TPI. Now I haven't got the right TPI insert for this, but it's not a problem as such. I'm doing 16 TPI, and I've got 11 TPI insert, which means that the actual tip itself is longer than what the thread depth is needed for this, if that makes any sense. So you won't get any, you shouldn't get any interference. Now, if I was doing, say, a 10 TPI thread and I was using a 24 TPI insert, that wouldn't work, because the 24 TPI insert, you don't have to go in so far, but the 10 TPI you do, so you'll go further and further in, you'll just destroy your thread and probably the insert as well. So what I'd do for the thread depth, because I still haven't got any charts yet, I use an app called Thread Calculator. External thread, Whitworth. Now the size, it's rare that I've taken a notice of the size, because that is well over the actual standard. But what I'm looking for is 16 TPI, which is that's well over 3/8. So the actual measurements, obviously I can't use those measurements, but I can work out the thread depth. So the external thread is the bottom one, obviously, so the OD, maximum 9.505mm, minimum 9.1. And you look at the D2, and you've got the max and the minimum there, so you've got to work out the difference between the two, and that gives you the thread depth. So what I'm doing is I've worked that out already, 1.946mm. That's off the radius. That's off the radius, lot, not off the diameter. If you do that off the diameter, then you'll be too shallow. So now that's out of the way, I'll keep the phone there, so because I'm more than likely to forget that number. I'm not going to go to the number. I'm not going to go 1.946. I'm going to go about 1.5. and then get the actual nut itself and test it, and then go a little bit more and test it. It's just an idea, so you don't just go wildly over. I'll get a pen. I've already done the scratch. Also, because it's right over here, I've got no dial indicator. The thread dial indicator that sits outside your carriage, where you get the numbers 1, 2, and 3 and 4, so you know when to engage the half nut or not. I haven't got one of those for this lathe, so I've got to leave the half nut engaged all the time, even though it's an imperial thread with an imperial lead screw. It's a 16 TPI, so it's an even number, so technically I could perhaps just disconnect it, move it, reconnect it, but I just don't want to run that risk now I've got this far into it. So I've got the control box here. I haven't moved it in any yet. I'll put it back to the actual start where it was. Actually, I've only done a scratch test so far, so I'll disconnect it. I haven't got any marker either. So if I've got a pen that works. I haven't got any layout die. So that'll probably be quicker. So imagine it's back gear into it, so it's... God, this is Mickey Mouse. Right, so I don't go in at 30 degrees either, or 29.5 degrees, or 24 point something. I just plunge straight in. I've got two dials on my indicator. Zoom in a little bit. So this is my method. There's loads of threading videos out there. So I use the main needle. Use the main needle for the actual depth, and I use the smaller needle for the in and out, or out and in, whatever. So I know that it's set at the moment for the scratch pass, which is 8. It's shown as 8. So once I've done it, I come out to 0. That's 2 millimeters. That's more than the actual depth of the thread. Get back to the start, move it back in the 2 millimeters plus a little bit more with that needle, if that makes any sense. Zoom back out again, so you should be able to see what I'm talking about. You're not going to see the thread, obviously, it zooms out so far. That's more for me to have a look at. So there we go. So first I'm going to go in, always throws me that is, I always expect the needle to go that way, because my other lathe indicated on the back. So I'm going to go in 0.15 on the radius. Engage the half nut. I love VFD control, so I've got a jog option. I want to go right up to the shoulder. That's it. Move it back to. This is going to get very repetitive, so I'll speed this up a little bit. Back into. So that's where it was, another 0.15. Sorry, 2.5, I'm saying 1.5 aren't I? I'm going 0.25. So I'm going 1/4 of a millimetre each off the radius until I get down to an actual close depth. Right, it's very important, hang on this, do you know I took the spindle out? When I took the spindle out to mess about putting that nut on, I always remember where the actual pin is. But, if you've got a faceplate, clutch dog plate or whatever you call them, faceplate with a slot in it, you haven't got that worry because you've only got the one slot anyway, maybe. But this, if you're using a 4-jaw chuck or a 3-jaw or a 2-jaw chuck to drive the lathe dog, you've got to remember between which teeth the actual pin goes. And if you accidentally, I know this is alright now because I've checked it, if you accidentally chuck it in, see that one, between those two, or in fact those two halfway round, you'll end up with a double start thread. Because when that tip comes to contact, it'll be 180 degrees from where it's supposed to be. So you'll end up having a double thread on your thread. What I'm going to do now, it's quite handy, well, it's handy for metric. I've got a triangle and a file, and they're 60 degree, obviously 60 degree angles on them. This is 55 unfortunately, so I'm going to go a little bit more careful. But it's only a diamond file. It's not like a bastard file or anything. It's not going to rip the hell out of the thread. So I'm going to stick this back out of back gear, put it in neutral, run it, and just clean the thread up. Onto milling the keyways.